Hello everybody, and welcome to your linear algebra review on Gaussian elimination in 3 variables. My name is Jason, and I work for the ASU Tutoring Centers. Now, if you haven't seen the previous video on Gaussian elimination in 2 variables, I highly recommend checking that out. In that video, I'm going to go over more of what Gaussian elimination is, what its goals are, and how we use it to solve systems. In this video, I'm just going to be applying Gaussian elimination to 3 variable case, to see what our solutions are. So recall, Gaussian elimination is the idea of using row operations to reduce your matrix down to row echelon form. Once in row echelon form, it's typically a lot easier to solve your matrix. So I'm going to show you every step to reduce this first system to row echelon form, and then the back substitution to solve it. For the second matrix, I'm just going to show you what the row echelon form is, and we'll use back substitution to solve it. Okay, so let's jump into it. So first things first, we're going to rewrite the first system that we have as an augmented matrix. So we have 6, we have 6, 2, 1 augmented with 9. We have 3, 0, 4 augmented with 2. And we have 5, negative 2, and 1/2 augmented with 23 halves. Okay, so first things first, first goal with Gaussian elimination is to get a 1 in the top left. That's always your first goal. So there's a couple ways you can do that. Maybe you can interchange 2 rows, and maybe one row would be particularly easier to get that 1 without getting like weird fractions. In this case, though, we can't really avoid weird fractions. Like if this was our first row, which it is, dividing by 6 is going to give us weird fractions. If this was our first row, like if we changed rows around and we made this one the first, dividing by 3 would give us weird fractions. And same thing here, dividing by 5 would give us weird fractions. So we can't really avoid having messy fractions. So we'll just stick with our first row, the 6, 2, 1 augmented with 9, and we'll get a 1 in that top right position. So I'm going to do 1/6 of the first row. It's going to give me the 1 that I want. 2/6 can be reduced to 1/3. 9/6 can be reduced to 3/2. And we're not changing any other row. Wonderful. So now that we have the 1 in the top left corner, our goal now is to get zeros beneath it. This is the typical strategy when doing Gaussian elimination. You get your 1 in your top left, and then you try to get zeros beneath it, however many there are. Once you have all those zeros, your goal next is to get a 1 in that position in the second column, and then you get zeros beneath it. And then a 1, and then zeros, and then a 1, and then zeros. And you just keep going until you've run out of space in your matrix. Right? That's the goal of Gaussian elimination. It's a process you can repeat every time, every single time. Get the 1 and then get zeros under it, and then move on to the next column and do the same thing. Okay, so to get a 0 in this position, we're going to go ahead and take row 2 minus 3 row 1. So the reason we did that, the reason we're doing row 2 minus 3 row 1, is because this right here is a positive 3. So to make it a 0, we need to subtract 3. So since we only have a 1 here, multiplying by negative 3 would give us that minus 3. And then if we add that to our second row, the positive 3 and then the negative 3 that we're making will cancel out. So that's the basic idea. Because we have a 1 in that top left position, we can now just multiply it by whatever we're trying to undo down here. So if we're trying to undo the 3, we can just multiply by negative 3. That's why having the 1 there is very important. It makes a lot of the math later on a lot easier. Okay, so we're going to take row 2 minus 3 row 1s. So the first row is going to be unaffected. So we have 1, 1/3, 1/6, and 3/2. Our third row is unaffected. 5, negative 2, 1/2, 23/2. And then our second row is affected. And let's see what it looks like. So we're taking row 2, so let's start with this element, this 3. 3 minus 3 times 1. 3 times 1 is 3. 3 minus 3 is 0. Just like what we wanted, right? Just like what we expected. We move on to our next element, 0. So we do 0 minus 3 times 1/3. 3 times 1/3 is 1. 0 minus 1 is -1. Then we do 4 minus 3 times 1/6. 3 times 1/6 is 1/2. 4 minus 1/2 is 7/2. And lastly, we look at this 2. So we do 2 minus 3 times 3/2. 3 times 3/2 is 9/2. 2 minus 9/2 is -5/2. Okay, so I went and I showed you every individual piece that we went and subtracted. For future ones, I'll probably go through them a little bit faster. Okay, so we have our 0 now. We have our 0 in this position, just like we wanted. Next goal is to get a 0 here. So maybe stop and ask yourself, okay, what row operation are we going to use? And the answer is we're going to do row 3 minus 5 row 1s. For very much the same reason as what we did up here, right? We're trying to subtract that 5 off. So our first row is unaffected. Our second row is unaffected. And our third row is affected. So when we start doing the math, we do 5 minus 1 times 5 is going to be a 0. We do -2 minus 1 times 1/3 is going to be -11/3. We do 1/2 minus 5 times 1/6, and that's going to be -1/3. And we do 23/2 minus 5 times 3/2, which is going to give us 4. Cool. So we have our first column done. We have the 1 in the top left and then the zeros beneath it. Amazing. Now our goal is to, as I mentioned earlier, right, we move on to our next column, and our goal is to get a 1 in this position. How do we do that? Well, we just got to get rid of the negative, right? So we're just going to go ahead and take, I'm going to continue it up here, negative of row 2. So we have 1, 1/3, 1/6, 3/2. We're going to flip all the signs in the second row. And then this bottom row stays the same. Fantastic. Okay. Next step is to get a 0 underneath this guy, right? That's like the whole process. You get your 1 and then you get your zeros underneath it. So to do that, it's going to be very similar to what we've done in the previous ones. We're going to take row 3 plus 11/3 row 2. And notice now we're comparing our rows to the second row. Like back here, we were comparing to row 1, right? That's because we needed to get the zeros in that first column. Now that we've moved past that, we don't really need to look at row 1 anymore. We can almost think that row 1 is done. We never really need to change it. We never really need to compare it to anything else. Now all we're going to be dealing with is row 3 and row 2. Okay. So again, we're changing row 3 here. So I'm going to go ahead. Row 1 is unaffected. Row 2 is unaffected. And row 3, once we do the math, it's going to end up being 0, 0, -79/6, and +79/6. And then our last goal is to get a 1 in this position. So we're just going to take -6/79 times row 3. So we get 1, 1/3, 1/6, augmented with 3/2. We get 0, 1, -7/2, augmented with 5/2. And we get 0, 0, 1, -1. So now our matrix is in row echelon form. Okay. And once it's in row echelon form, we can now use back substitution to solve our system. So just like at the beginning of this problem, we took a system of linear equations and converted it into a matrix. Now that we have a matrix in row echelon form, we can sort of work backwards, and we can convert that matrix into a system of linear equations. So let me go ahead and finish erasing, and then we'll see that in action. Okay, so we're looking row by row in our row echelon form matrix. So remember, all of these elements of the matrix are just coefficients in front of your variables. So the first row is going to read, you have 1x1 plus 1/3 x2s plus 1/6 x3s equals 3/2. Then you go on to your next row. So you have x2 minus 7 halves x3 equals 5 halves. And then you have your last row, which is x3 equals -1. So the last row just tells you what x3 is, just telling you that x3 is -1. And then what do we do to solve for our other variables? That's what the back substitution is. So we substitute this back up there. So we get x2 minus 7 halves times -1 equals 5 halves. So that's x2 plus 7 halves equals 5 halves. So subtracting it over, we get x2 equals -1 as well. And then to get what x1 is, we're going to take this x3 and sub it in there, and this x2 and sub it in there. So you work your way backwards with the substitutions, which is why it's called back substitution. So we have x1 plus 1/3 times -1 plus 1/6 times -1 equals 3 halves. And then after simplifying and solving, we get x1 equals 2. So the solution to this system of linear equations here is that x1 equals 2, x2 equals -1, and x3 equals -1. Cool. We can also, instead of writing it parametrically like this, like 3 separate equations, we can write it as a vector equation. We can just put the variables x1, x2, and x3 into a vector and say it equals 2, -1, -1. So that is our solution to the first one. Okay. Cool. I'm going to go ahead and clear it now. So to look at our solutions to the second one, we're not even going to do the process of Gaussian elimination. I'm just going to show you what the row echelon form looks like. The process is very similar to what we just did. So first, if I were to look at what our matrix looks like, it's 1, 7, -3 halves, augmented with 15. We have -1, 4, 0, augmented with 10. And we have -2/3, -14/3, 1 augmented with -5. Now, once we get it in row echelon form, it's going to look like 1, 7, -3 halves, augmented with 15. 0, 1, -3 20-seconds, augmented with 25 elevenths, and 0, 0, 0, 1. Okay, now keep in mind row echelon forms, because there's many ways to get them, right? You decide to maybe swap rows when other people don't, or add 2 rows together when other people don't. There's many ways to get them, so there's many ways that they can look. So maybe you did the process of getting it in row echelon form and yours didn't look like this. That's okay. You'll still end up getting the same answers. It's just that the process to get there was a little different. So now automatically, we already know we're going to have no solution to this equation based on this line here. The left-hand side of it is 0x1 plus 0x2 plus 0x3, which is just 0. And then the right-hand side is 1. So we're claiming 0 equals 1 with this bottom line, which doesn't make any sense, right? 0 clearly does not equal 1. So this one has no solution. Okay, so the first one had a solution. Second one, no solution. Cool. All right, I'm going to go ahead and clear this again. So on this other slide, as I mentioned at the beginning of this, I work for the ASU tutoring centers. So if you want more information about the free services that we offer to you on all 4 campuses and online, please check out tutoring.asu.edu. Instead, if you want videos that are more like this one, where we go over specific concepts in your course, or maybe you want to see what upcoming review sessions we have for the exams in your course, you can check out this link more specifically. Cool. Thank you again for watching this video, and have a wonderful day.